This conference will now be recorded.
All right, folks, welcome to our live session. Let's get started. So today's topic is designing Kafka, and this is a very important topic for a very specific reason, and that is that you don't find this explanation anywhere. Like it's sort of like the elephant in the room, where everyone knows this is important, and everyone sees companies asking this, but it's hard to find um, an explanation anywhere, or any good explanation. So we'll try to get into that today and fix that today. So what exactly is Kafka? So Kafka is what you would call a streaming log, or some people would call this a commit log, or other people might call it a publish subscribe system or pub sub system. So, all of these different sort of terms for this fall into the same category. Kafka is all of these. So if you're asked, design a commit log, design a streaming log, design a pub sub system, you could use Kafka as a implementation of that. Any questions about that? Has anyone been asked this question before, like design Kafka in an interview? I'd be curious to know. Okay, so let's get into the difference between a distributed queue like RabbitMQ and the difference between and Kafka, right? Because this is something very key in understanding. When you think of a publish subscribe system, it sounds like, hey, isn't this just another queue, just that the queue is called a topic, right? And so you subscribe to a topic and you publish to a topic. Well, actually, there's a big difference. If you use a queue or a RabbitMQ, um, you cannot handle the use cases of a publish subscribe system. And so here's why. Okay, so what's the difference? So the big difference is that, in a queue, you put items in and you take items off, right? It's a first in, first out system. So you read from one end, you write to another end. Okay. Kafka is a streaming log. Okay, which means that you can start reading from anywhere in a topic. So in a queue, you cannot say that, hey, I want to read from point from offset like 200. Like, start reading the queue from offset 200 and read me everything starting from 200 to now. You cannot do that in a queue, right? Because in a queue, the default operation is take item off. You cannot reference a particular element in a queue, then it won't be a queue anymore. Whereas in Kafka, right, or any streaming log, any consumer, so let's say you have let's say we have a logging use case where you're sending a bunch of logs into Kafka, right? So these are logs coming from users. So let's say user clicks or user views are all coming in here, and this is a Kafka instance. So different consumers might want different, might read at different times. Okay, so let's say you have an analytics pipeline here. Okay, they might want to read from let's say over here, right? They don't want to start reading from here because they've read everything before that. Or another reader, let's say that there's a let's say backup archiver or something, right? They're doing periodic backups every day. Let's say they want to start reading from this point, okay, because they've read everything before that, right? So they're specifying an offset saying, hey, read from this point. This is something you cannot do with a queue. Any questions about that? Does that make sense?
So is this a pull model? Like, is the subscribers pulling from these particular like 3984 4794?
So in this case, what happens is you subscribe to a topic and you start somewhere. So you establish a connection, and then it's like reading from a file, right? Kafka sends everything up to the latest value.
Oh, so when you subscribe, you tell, okay, what is the offset from which I need to get, and from there on, the Kafka pushes it from there, that
Yes, yeah.
point.
So you establish a persistent TCP/IP connection, and then Kafka starts pushing from there.
Okay, so during the subscription, it has the provision to specify the offset.
Yes, absolutely. Yeah, yeah.
Okay, got it.
Yes.
Yeah.
Yeah, you could also, if you don't provide an offset, it could also read real time. So
Yeah,
if you
got
just
it.
say, let's say that this one here wants to read real time, um, in that case, they will start reading from the end over here.
Even in the offset case, once uh, there will be a certain point at which it will start real time again, right after the previous messages are read.
Yes, it will. It will. Yeah, yeah,
Okay.
yeah. So it'll be everything after that offset. Yeah, yeah. Good question. Other questions? Okay. So another key difference here is that um, because we have to maintain, like we have to sort of, any consumer can specify a byte offset. So we have to store the data for a while, right? We cannot just, like a queue where once the data has been processed, we can just get rid of that data. We cannot do that here. So how do we store data? So like, how do we know, like, we cannot store data forever though, right? You cannot store logging data forever. So how do you know like how much, like how long to store some data? So that is something that you specify an expiry time, or time to live, um, or time to delete. So in Kafka, the default time that the data lives is 7 days. So like 1 week. And we sort of assume that if you haven't consumed that data in 1 week, like everyone who needs to consume that data would have consumed it in 1 week. So we assume that 1 week is enough for all consumers. But this is configurable, right? So if your pipeline needs some more time, you can configure this from 7 days to like 2 weeks or 1 month or something. Of course, it'll end up using more storage, and so you'll have to pay more for the infra, but you can always do that. Any questions about that? Does everyone understand the difference now between Kafka and RabbitMQ or distributed queue? Because that's probably one of the key things here that people get confused with a lot. Okay, cool. So like on the face of this, like these differences might not look too big, because you might argue that, hey, it's still a queue, it's just that we're saving the queue or something, right? But this actually changes the underlying implementation quite a bit. So instead of thinking of this as a queue, it's it's more um, it's more cleaner to think of this as a file system, right? And to think of this like, entity we have here, like this, what we're storing here, instead of thinking of this as a queue, you could think of it as a file. And it'll be clearer in a minute. So like, let's say we invert this, right? Let's say we take this, right? So we have this, and let's say we rotate it by 90 degrees, okay? Now all of a sudden, this is looking more and more like a file, right? So you have some byte offset, and you have like readers reading from the file, starting from that byte offset, and so yeah, you can see that now this looks more like a file, and so it's important to think of Kafka as a distributed file system. So that is a key mindset shift that you should adopt. Like if you just remember this, if there's nothing else you remember from this talk, it's you could remember this, that think of Kafka as a distributed file system instead of a queue, right? Because this will sort of trigger the rest of the implementation, right? Because the rest of the implementation is based on file systems. Any question about that? Okay. So let's say that we have a distributed file system and we're writing, like writers are writing to this file system and readers are reading from these files. So we'll go into later into how we achieve more higher throughput. Like you might think, oh, file system sounds slow. Like why would we write to disk every time? So we'll get into how to make it efficient. But for now, just think of it as a file system. Um, so let's say we have high throughput requirements, right? So one machine doesn't cut it. So here we have one machine and you have a bunch of producers and you have consumers consuming this file, and this works well until the number of users increases and the load increases and throughput increases, and now this one machine is not good enough. So what do? You, of course, you just add another machine, and so you sort of create partitions similar to what we did with distributed queues, but in this case it's with the file system. So we have, let's say this is partition 1, Okay. And we have a bunch of producers and consumers. So let's say that people are reading partition P1 from at any point. Okay, so we have our 3 partitions. And of course, we have a bunch of producers. And they're all, so now they can write to a partition of their choosing or a partition that's assigned to them. Okay, and now we're assuming that this is one topic, right? So um, like so we've sort of partitioned a topic into 3 partitions. And each of these is a different machine. Any questions so far?
Can you give an example of topic and a producer's? I'm guessing in here it's servers generating logs, but maybe in a use
Yeah,
case
that's a good
scenario,
point.
how that would look.
That's a good point. So let's say that this is Amazon's home feed data. So so let's say that this topic is Amazon.app.homefeed. So we have an Amazon mobile app, and in that mobile app, the user will be scrolling, they'll be looking at items, they'll be clicking on items. And so all these activities from the user, let's say we're taking those activities and we're sort of logging them, right? So user activity from a mobile app. So this you would have like clicks, views, time spent on each home feed item, and so on. And so this will be a high throughput topic, and every single phone's data will be sent here, right? And so that's an example of one topic. Does that make sense?
Yeah, that makes sense. And in this case, the producers are those mobile, the users, or would that be the servers?
So this would be some server that's getting that data and forwarding it to Kafka in this case. So like there'll be some logging server that is receiving the logged items from the mobile app and then forwarding it to Kafka,
Got it.
right? Yep, yep. And so like, in fact, 3 partitions are not going to be enough, right? This topic. And so like, this is a topic. So you see that this Amazon.app@homefeed is one topic. Along the same lines, there could be an Amazon.app. Let's say shopping cart, right? Cart. And so cart-based events might go into that topic. And as you can see, to have 3 partitions is probably not going to be enough for such a massive topic. So in this case, you might need like 100 machines or so. Yeah, good question. Any other questions people have around this?
So you want to use Kafka in cases where the ordering does not is not that important, right?
Like the exact ordering of,
Yeah,
if,
the click, so the
yeah,
views, right? That order does not matter, right?
yes. So like you don't need to store things in exactly a particular order. Um, so anytime you distribute a queue or distribute like something like this, the ordering might get a bit off, right? Because let's say that, this, something was generated at, 4 seconds here and 2 seconds here. This is the time. Like let's say 2 p.m. here and 2:01 p.m. here. Um, this might reach 2:01's data might reach P2 before 2 p.m.'s data reaches, right? So yeah, ordering, like, it doesn't have to reach exactly in the time that it was generated. Yeah, so ordering can get screwed up, but if you really care about ordering, like there's always timestamps, right? Usually in these logs or items, there's timestamps, so you could put a timestamp to it and then later on sort it or something if you really need it.
Is there a mechanism where they hash it and send it to the same partition?
Or will they hash it and send it to the same partition? Um,
Like, are there any real life cases like that, or
so typically for something like Kafka, right? I think you would just create a different topic for that. Um, like if you need some, like I guess you're saying like if we need some localization, typically that's more of a storage thing. Like if you want to store something and there's more, you want to make sure that everyone who has a certain, everyone who's in a certain, um, let's say, location goes into one storage server. That's typically more of a database thing, I would say. In Kafka, if to do that, you would just create a different topic.
For example, if a user is on that home feed and you want to trace his or her behavior and whether they buy the item or not, those sequence of events might be all over the place on different partitions, right? Meaning they would have the timestamp. You would have to aggregate that and sort it out to figure out where was the time, some sort of analytics if you were trying to find time to time to cart, did it stick around, or what happened to some sort of
I see.
behavior patterns. You would have to aggregate it at some point later on, or I think that was
That's
the
true. I
question
guess
close.
I see. Okay, okay. So I think that makes sense. Yeah, yeah. So like if it makes sense that like one user's data goes into one partition. So I guess you could set your key uh, such that like the user ID is part of it, and then I guess try to make sure that all items from one user go into one partition. I guess you could do that. I'm not 100% sure though about that. Yeah, if anyone's used Kafka for that, feel free to jump in. Okay. So, so I think it's important to note that each of these things is one file. So So Amazon.app let's say that this is a file system. So this might be stored in Amazon app home feed partition 1.log. This could literally be the name of the file. Okay. So before we move on to deeper details, any other questions?
So, suppose, say it's the logs are for the clicks, okay? So, and the producer is um, sending that to one machine, then at a later point sending it to the second partition, like that. So, for the reader, he has to subscribe to all the partitions.
So typically readers will so they won't subscribe to all the partitions. So, well, I mean, it depends. If they need to read everything, then yes, they will have to, like, if let's say it's a backup job or something, right? So, uh, yeah, they will have to subscribe to all the partitions and get data from there. So, in most cases, right, I think, uh, honestly, most of the processing in Kafka, like, there's two use cases, right? One is the reading an offset, and the other is reading real time. So, if you're reading an offset, so let's say you're generating backups, you're doing some analytics over a period of time, then it's okay to read one at a time, right? Because it's sort of an offline job. So you don't need to like subscribe to all partitions at once. You could read them all, separately or two at a time or something like that. And ideally, if each partition probably has a timestamp, so like when that, you know, click actually happened. In the real-time case, so in the real-time case, there's an interesting trade-off here, which is that let's say that because the throughput is high, right? Um, let's say you're doing some real-time stats. Okay, you want some graph, you're maybe calculating the throughput or something. In that case, yes, you would have to read from all of these, but you also need to be able to like ingest all of these at once, right? Remember, the reason we partitioned it is because we weren't able to handle throughput in one machine. So the throughput is probably going to be high for reading also. And so it may not be that one machine can just handle subscribing to all these partitions. So we might actually need multiple machines even to read multiple partitions. Does that make sense?
Yes.
Yeah, so in fact, let's say you want to create like a real-time log observer, right? And let's say that you just pick one machine as a consumer of a topic, or subscriber, I guess is a more apt term here. And let's say you just read logs from this subscriber, okay? You don't read from other subscribers, just this subscriber. For the user's perspective, it won't make a difference because they can only read so many at a time, right? You can only render so many live streaming logs at a time. So even if you just render that from one partition, for a user, that won't make a difference in a log viewer, let's say, right? Or if you're observing some streaming logs, or if you're doing some approximation of um, some sort of a um, click data, let's say you're saying what's the average rate or something like that. Um, so a lot of times you could just use one partition if you want to just get a rough idea of the real-time clicks or whatever data. But generally, what would happen is you would, if it's real time, right, you would read into multiple subscribers, and then these subscribers will aggregate them. So let's say you want to create like average click time over the last 1 hour or something. Then like you could read from multiple subscribers. Each of these will aggregate their stats, and then you could combine those stats into one. So something like that.
It kind it kinds of get complex, right? When if you want to say, okay, I want to read from this offset, I also want to specify the offset of a particular partition, right? How does that work? Well, like say a subscriber comes and says, okay, I want to read all the logs of the clicks um, from this offset. So I also need to specify the partition, right? Because the offset is specific to a partition.
Yes, that's correct. That's correct. So um, yes, so you do have to specify from each partition. Yeah, you're right. You're right. So the offset is for each partition. Like I think Kafka has that concept of like, I think they call it segments or something. And so each topic will have segments. These partitions are just called segments. And then from each segment you can you can each segment's byte, like each segment starts from byte 0 and then goes from there. Oh wait, I believe, sorry, not segment. That's called partition. No, it is called partition. Yeah. So each partition starts with byte 0 and then goes. Um, segment is even more granular, which I'll go into in a bit. But yeah, partition will start from byte 0.
A single machine can have partitions for two topics, two more than one topics.
Yes, yes, I believe so. Yeah. Yeah. Great questions. Any other questions? I'm sure there might be other questions here.
Um, so throughput wise, uh, why do we say that Kafka is having a higher throughput than a queue? Because I see the main difference is the once an item is removed from the queue, it cannot be consumed by any other subscribers.
Hmm.
But that's not the case with Kafka. But throughput wise, um, do we really go for Kafka when we have a high throughput requirement, or we don't take that decision based on the throughput?
No, I don't think you take that decision usually based on the throughput, because like you could just you could have the same throughput on a queue, right? Maybe you'll need more machines, but you could serve the same throughput in a queue as well.
Okay.
Um, so I think what you're talking about is like per machine, Kafka is more efficient, like it can handle more throughput than a queue. Um, there's a couple of reasons for it, and let's get into that. Actually, that's the next topic. Like, why is this high throughput, right? So let's get into the nitty gritty implemented. So um, let's go into one specific partition and see how we're doing writes and reads over there. So
So
let's
the
say we
pri-
have a machine. Sorry, go ahead.
so the yeah so the primary reason why we choose either Kafka or message queue, uh, what is there, like when do we choose Kafka or message queue?
Oh, so that's depends on the use case, right? If you need
Okay.
a task queue where it's like where it's a job that needs to be get done and then offloaded, right? then you use a queue. So in a queue, you cannot do, like, you cannot go to a byte offset, right? You
Yeah,
it's mainly for tasks or something that's first in, first out.
correct. And also, like, if you want to send an item to multiple people, right? Multiple people are listening,
Right.
then
Yeah.
you cannot use the queue, right?
Yes,
So you
exactly.
have
Yeah.
to go for the publish subscribe pattern, which is in Kafka.
Yep. Yep. Exactly. Yeah. Okay, so let's look deeper into a machine, and let's draw a line between the RAM and the disk. Okay, so let's say this is the RAM, this is the disk. Okay, so now we have a um, so we're going to see how this file writes that we write, and these writes are to the disk, right? So when we write these partitions, like these partitions files, right? They live in the on the disk. So we can see we have like a little file path here, partition1.log. So it actually lives on the disk. It's not just on. You would imagine that, hey, it's a high throughput system, so just like a queue, it should live on the RAM, right? Why are we writing to disk every time, right? It might seem inefficient to you. Um, well, it is in a way, but there's a reason why this ends up being efficient, and that's because by default the file system will have a buffering for it. So let's not get ahead though. Let's first talk about how this works. So this is our Kafka file. Okay, and you have readers and writers here. Okay, so you have consumer one, consumer two, and the reading from here. Okay, and the logging server, let's see, we have a log server here. And let's say that server is writing to the end of the file, right? So they will write here to the end. Well, okay. So the path to write will actually go through RAM. Right? So the path goes from here, okay, in RAM, and the RAM will have some sort of a process, right? Like a readers, like file read write process, and it'll call write to file or something. Okay, like a function write to file. Okay, and that function will then do the actual write to the file. Okay, does that make sense? Any questions about this? Anyone have any questions? Should be pretty simple, right? So this is our file here, partition1.log. This is our file here. Okay, so now there's going to be multiple of these log servers trying to write to this file. Okay, so maybe more here, more here. Okay, so this is a high throughput environment. Now, there's an obvious inefficiency here, right? Can someone point that out?
The bottleneck, right? The throughput bottleneck is
Right.
there.
Where is the bottleneck here?
Um, so basically, the log service will have to wait for the RAM to dump it into the disk, right?
Right. Yeah. And disk writes are pretty slow, well known to be slow. Even sequential disk writes, like random writes, of course, are extremely slow, but even like uh, sequential writes to disk, they're pretty slow, right? They're, at least 100 times slower than like RAM. If you were to write, like instead, if you were to just have like some buffer here, right, and just write to that buffer, that would be 100 times, I believe, faster, or something along those lines. Um, I don't remember the exact numbers right now, but in the course we have this section called numbers everyone should know. And it's also available online. I believe it's by Jeff Dean, where there's a slide of all the how long it takes to write to disk, how long it takes to write to RAM. And sequential writes to disk are quite slow. So if we are relying on these writes, right, this little arrow here is going to take a long time. And so that's going to really crush our throughput. Um, so, but Kafka works like this, right? Kafka does this. And so why does this work? The reason this works in Kafka is because they utilize something called the uh, the page cache, like the OS page cache, so operating system's page cache. And what it essentially is that it's a buffer that the operating system provides by default. And a lot of you, so how many of you are familiar with like the OS buffer cache or page cache? Maybe you could type in the chat if you've heard of it before or know about it. And how many of you don't know? Like if you could type yes or no. Okay, so there's a no here, there's a no here. Okay, cool. That's great. That means that for most of you, this will be very useful. Actually, most of you have typed no, so perfect. Great, excellent. So essentially what the operating system does, so let's actually rewind and let's look at how a write to a disk works in the OS, and then we'll come back to this diagram and we'll add that little buffer here. But let's see how writing to the OS works. Writing to a file works in the operating system. Because this is like the core concept of why Kafka is fast. Uh, so let's say that this is a file, okay? And this is obviously on disk. And let's say that you do a write. So this program here, write to file, let's move that down here. So let's say we are writing to this file starts from byte 0, so 0, let's say kilobyte, right, and goes all the way to like let's say 1 GB. Okay, 0 to 1, 0 to 0 kilobyte. Um, and let's say we are writing to byte number 0 first. Okay, we're writing to the starting of the line. So we do a write to byte 0. So you can write to um, so let's say we say in a write file like write, let's say we have a character, okay, write character A or character Z to byte 0 in file partition 1.log. Okay, let's say this is our command here. So what the operating system does is that it won't directly write to file. It'll instead load a buffer in memory, and it'll write to that buffer. And this buffer will correspond to a particular part of this file. Okay, so let's say that different operating systems have different sizes of this buffer, but let's say that Linux usually has x86 has 4 KB buffer size. So let's say the operating system loads 4 KB of the first four, let's say first 4 KB of the file. The OS loads that into memory, okay, and does all the writing in this 4 KB buffer that we've loaded in memory. So this is RAM, right? Everything above the orange line is a RAM. So it loads these 4 KB into memory. And so every write, so let's say you write byte 0, and then you write to byte 1, you write to byte 2. All of these writes don't actually go into the file. They go instead into this buffer. Okay, so we're not immediately writing to the file, we're writing to this 4 KB buffer. Okay, and eventually we'll flush this 4 KB buffer back to the file, okay, eventually. And this can be a time that the operating system sets. This could be anything depending on the OS, but like a common one is 30 seconds, right? Or maybe even 10 seconds, but 30 seconds is one common number I came across. So eventually this, what's called a page cache, okay, this is a cache, right? This is a cache of a page of the file. And this page is a 4 KB page. Does that make sense? So if you have a file, let's say this file is, for now, let's assume a simple number. Let's say this file is 40 KB, okay? Logically, the OS will divide it into 10 4 KB pages, okay, 4 KB each. And it'll load the page which corresponds to the current write. So if you're writing to byte, let's say byte 5, right? The second page will be loaded into memory. Okay, it'll load the entire 4 KB page as we did here, and then write to that. Okay. Does that make any question? I'm sure this is a bit confusing, right? The page cache. Any questions about this?
So uh, Kafka is specially programmed to use this OS mechanism.
Yes.
So all other applications do not, say, our normal applications do not use this mechanism.
Oh, they do. They do. So yeah. So like Kafka doesn't need any special program to use this. They can just write the file and they just assume that the OS takes care of it.
So that is the one that makes Kafka's different. Since they're using this page cache mechanism, that is how they are achieving this high throughput.
Yes. Yeah. 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 In
So
fact,
any
go ahead.
application which we develop, if we use the page cache mechanism, will have like high throughput, right?
Um, if that application's read write patterns match that of the page, it just happens that Kafka does sequential writes, right? It's only sequential writes and sequential reads, and page cache happens to be like just optimal for sequential writes and reads
Okay.
because and the reason is that it's probably obvious that you're loading 4 kilobytes at a time, right? And so any subsequent reads will always go into the same page, right? And then what the OS can do is they know that it's sequential, so they ahead of time they'll load the next page cache ahead of time. And so all the writes, because they're sequential, the OS can really easily predict that, okay, the next cache I'll read is the next one, right? If your application requires random writes, right, then this is not going to be as efficient. Does that make sense?
Yes.
I have a quick doubt.
Yep, yep,
So, yeah, so from the buffer or page cache, every time 4 kilobytes of the file will be loaded onto the disk, right?
yep, yep.
So what happens? Will these bits, I mean, like these 4 KB data that is going on disk, will it be available to the consumer, or will it only be available to the consumer once entire uh, data is returned to the disk?
That's a good question. That's a good question. So I believe that I think reads. Okay, I need to confirm this. I believe reads and writes have different caches, or do they not? Let me check real quick. So I guess you're asking, while this page cache is in memory,
Hmm.
can a reader read it, right?
Yeah.
So I believe that I believe that because the read and write processes are different.
Mm-hmm.
No, actually, I think they should be able to. I think they should be able to. I believe they might share because I think the file has a common page cache. So I believe that it should be able to, the reader should be able to read it. Yeah, yeah,
It will be able to.
yeah, should be able to.
When you open a
Uh,
file, the file descriptor is pointing to a table where it contains which pages are in memory, and the operating system default page size is 4K. And if it needs more, when you miss, it goes to the disk and reads it.
Oh, okay.
Write back is the opposite.
Okay. And what happens if there is no data? Like it just stops reading. Like what if it gets a failure, or if there is no data?
so what do you mean by no data? Like, if we
Like
run out?
what if a consumer is trying to read from a partition, but there is no data there? Like whatever
So
the
like the file is 1 gigabyte, but they're trying to read like 1.1 gigabyte by
no, no.
offset.
No, no, no. So what if the 4 kilobytes is still in the page
Mhm.
cache and it's still not loaded to the disk?
Oh, I see. So then they will, well, but they will end up reading the 4 kilobyte in memory, right?
Okay, they'll
Because
read
that
from
4
the page cache then.
yeah, because that cache is in memory. So I believe, and people can confirm if this is right or wrong, but they should read from the page cache if it's in memory.
Okay. Okay. Thank you.
Yeah, yeah, good questions. Yeah, other questions people have. I'm sure there must be many questions. This is not a simple topic to understand if you're seeing it for the first time. Um,
I didn't really get the idea of the sequential uh, writes. Is this
mm,
like so? For instance, you have 1 gig to write, for instance, to the disk. You have to go from byte 0 to 1000 like in order. Like there's no way to get like whatever available. Let's say I guess there's no availability here. I mean, you have to go like one by one. Is this like right or?
yes. Well, so I think one thing important to note about Kafka is you're always writing to the end of the file. You're not really overwriting in the middle, right? So you're always writing to the end. So in fact, this 4 kilobyte we've drawn here, it should actually be at the end of the file in this case.
I see.
So because we're always writing to the end, sorry, I guess I didn't understand your question completely. Can you maybe repeat that?
Yeah, like when you said about the sequential write, this means like if I have 1 gig, this means that I'm gonna go from byte 1 to byte 1000, like in order, like 1, 2, 3 till the end,
Yes,
or
always. Yeah, in Kafka, always. Because it's like you're just adding, you're appending, right? There's only appending going on.
I see. Oh, okay, okay.
Yeah. You're streaming, right? So you're always appending to the file. You're never like modifying the file.
Okay. Is that like the same, um, like MSQ or RabbitQ? Is it the same thing?
Yes, absolutely. They do the same thing. Even in queues, you're always appending to the queue, right? But that's not a file. The queue is typically not, well, it might be underlying, but it's a first in, first out structure, right? So it's a
Right.
different use case, yeah.
I see. I see. Okay, got it.
Like technically you could implement a queue from a file, right? Like technically you could do that. You append to the file and you read from the top of the file, right? From the top. So you could implement a queue with just a file, right, on the file system. You could theoretically do that. The problem with that would be you'd have to figure out how to delete an item because you have to always delete from the beginning of the file, which is doable, right? Which is doable. So you could technically implement a queue from a file. Yeah, you could.
Yeah. So, okay, another question, Harsh. So, since you're writing to the end of the file, let's say you wanna scale that file a little bit, like add more. Is it gonna like the pointer is gonna move like immediately, or takes time, or what happens in this case?
Sorry, so if you're writing to the end of the file,
Yeah. So you're always writing to the end of the file, so that you're
hmm
always gonna get to the the most available like kind of space. But now,
hmm
let's say you added another space to that file, or just like you have a dedicated space for each file. You cannot like expand that 1 gig to make it like 2 gigs for the same file.
mm. Um, okay, so you mean if we run out of file space, you're saying?
Yeah, for a specific file, let's say if you have one
Got
file.
it, got it,
Yeah.
got it. I see. So, okay, that's a good point. So the OS will typically not have. I mean, are you saying the OS has a limit on the file size?
Yeah, like I guess when we so my understanding is when you have like 1 gig file, like what you have drawn here,
Hmm.
um, this 1 gig, let's say is full now, and we want to expand the space a little bit
I see.
to make
And
it
1 gig is, but why can't we expand the 1 gig, the file size to 2 gig, right?
Yeah, we
The
can, yeah.
file can.
But what's gonna happen for the reading? Like
Got it.
you always read to the end, or I mean, writing to the end of the file.
Right. Yes, yes, yes. Okay. So you're getting into a good topic. So, yeah, so generally you want smaller files, right? You don't want to grow a file in an unlimited size. Um, so I believe Kafka has a limit of 1 GB. Like generally this file, and these are called segments. So within a partition, there's segments, which are essentially, if a file exceeds 1 GB, then we start a new file and we start writing to that new file. Um,
I see. Okay.
yeah, yeah. That's how Kafka handles it.
Yeah, makes sense. Okay.
Yeah, great question. Any other questions? I'm sure there's still a lot of confusion here. Anything that's not clear? So we could pretty much apply the same thing to reading. So far we talked about like why are writes fast. Um, in reading, it's the same thing. So in reading also, we will have this page cache, right? File page cache. When we read a particular byte, let's say we're reading this byte over here. Let's say this is byte, I don't know, let's say this is 100 MB or something. The point at which we're reading will be cached, right? In a 4 KB cache, 4 KB page. And because the reads are also always sequential, the OS knows that, the next page that'll be read, it's the next one. So it'll preload those pages in memory. These are called, I forget what it's called, read ahead caching, or does anyone know the term for this? Read ahead something, read ahead caching, I believe, is what it's called. Essentially, the file system predicts based on, you know, based on how your, uh, based on the pattern of your reads. So it knows that your reads are, it looks like your reads to the file are contiguous, right? They're sequential. So it'll predict that, okay, the next read will also be from sequential, and it'll preload the next bytes into memory. And this is why reads are also super fast. Does that make sense?
And this is something which the OS provides by default, or we need to tell the OS that we need that
It's
support.
by default. It's by default, yeah. Yeah, this is why Kafka, the implementation of Kafka is actually much simpler than it sounds within the OS, like within the file saving and stuff. They basically this is the efficiency that they brought in compared to queues. So in a queue, what you would do is you would create like a separate buffer. In many applications, you would create a separate buffer in memory, and you would manage that buffer, right? Read or write. They just got rid of that buffer, so you don't have that extra overhead to manage. And that was like one of the key, I guess, developments that they did. Like they identified that for this kind of use case, you don't need any of those complications. You could just use the underlying OS.
So what exactly does Kafka do? It looks like it's using OS features here.
So
Correct, sir. That was the exact question I also wanted to ask.
yeah, they do everything on top of this, right? So managing partitions. It's Kafka. Yeah, you're right. Like the implementate, like whoever created Kafka, right? The creators who now they have a very successful company based on Kafka for Confluent. No, I forget the name. I think it's Confluence or
It is
something.
Confluent, yes.
Confluent, yes. So yeah, so Kafka, the implementation is more on the management layer and less on the file system layer or storage layer. It's more of like how do you distribute these topics into different machines? How do you manage partitions, um, assign partitions, all of that. Also, like these files are uh, like you have to manage a lot of things here. So, for example, we talked about segments, right? So, so in Kafka, uh, because these are large files, the you cannot just have uh, 10 gigabytes, 100 gigabyte files, right? So what they do is they divide each of these into 1 gigabyte files. Okay, so you're writing 1 gigabyte files at a time. So this whole, let's say this is a partition P1. Within the partition, they have these 1 gigabyte segments. And segment is essentially like a file. Okay, so each file is 1 gigabyte in size limit. And so now, like when a writer, let's say a reader comes in, right? Right, each of these files will start with byte 0, right? We'll start with byte 0 and up to 1 gigabyte. But logically, our partition is not, our partition has its own byte offset. So our partition should start from byte 0 and all the way to like 10 gigabyte or whatever. So they do this mapping of, you know, let's say that a request comes in and they're requesting for, let's say 3 gigabyte, right? Offset of 3 gigabyte. So they have to maintain a table of these segments, right? Which segment corresponds to which byte range. Does that make sense? It's a bit more in depth, but essentially, like they have to map from map all these segments into one file in a way. So this kind of management is all handled by Kafka, right? The underlying file system they can use. They have the luxury of using the default, but they have to do a lot of management. Does that make sense?
Okay, so they keep a map of which, when you ask for a topic, and in that topic you're requesting contents after a certain offset, they know which files to go and pick from.
Yeah, yeah,
Or if you're adding content, where does it go?
yes, exactly, exactly.
So if you look at any single file, it could contain multiple topic information. Is that fair to say?
No, because so here's how the hierarchy goes. It's in Kafka, right? And programmers can use this in Kafka. So it's topic, and then partition, and then segment. So the programmers can access at a partition level. And each partition is treated as a single file from 0 bytes all the way to, let's say, like 100 gigabytes. The segment is mainly for limiting the file size to 1 gigabyte. So each segment is 1 gigabyte, and that is handled internally. So as a user of Kafka, I can just say, hey, partition P1, give me a byte offset, like, I don't know, 50 gigabyte. Give me this byte offset. And internally, Kafka will handle will figure out which 1 GB file has this byte offset and return data and start reading data from there.
Okay, so one topic can have multiple files, uh,
Multiple
and
partitions. Yes.
yeah, which
Logically,
boils
the
down,
partition is a file. Yeah.
yeah, and that boils down to multiple files in the end. But
Yes.
any given single file is not shared by multiple topics
Nope.
or
Nope.
partitions. Okay, makes sense.
Yep. Yeah. Yeah. So Kafka has to maintain a table, um, something like this, where they do a essentially like an offset mapping to like the to which partition maps it. So they'll say like, okay, message offset. So the terms used in Kafka are message offset, like the message, what offset does the message have, instead of byte offset, and so it maps the byte offset to a file. So let's say this is message 0000, then you have message 00 or some large number. I'm making small numbers right now. Right, and so it'll correspond to a file. Okay, this is the offset. So let's say someone requests, give me message 00400. Okay. So now 400 will lie, as we can see here. 00398 is here, so it'll lie in segment 2. So Kafka will start reading from uh, segment 2.log. So from a user's perspective, there's partitions and there's messages and message offsets. So the user can say, okay, I'm at message offset 400, start reading from message offset 400 in partition B1. I mean, this might get a bit complicated. So I think it's, from the interviewer's perspective, generally, I think they will do it till partition, right? Partition is where partition's the interface to the user, right? And then segment is the internal details. Any questions about this? So now we can sort of finish this diagram and we can add this page cache to this. Yeah, any questions? Does this make sense? Maybe now it makes more sense how we are able to achieve this diagram here. Any questions?
So the page cache and the sequential writes, that is what makes it really fast, right?
Yes, yeah, yeah.
So if it is a non-sequential write, right, the OS will not give this support. Is that right?
Sorry, who will not give this support? The OS.
The OS will not give that support.
Yeah, so if it's non-sequential, then the OS will have to read from disk, right? So it ends up being like reading from disk. The OS cannot predict ahead of time which cache will be read. So then you end up doing something like a buffer queue or something, like implement your own buffer, yeah, stuff like that.
So Kafka or any application will have to tell that, okay, I'm going to write this sequentially, so that that support kicks in from OS.
It doesn't. I don't think it needs to explicitly tell that, because I think the OS itself knows that sequential writes, if it sees writes and reads coming in sequentially, it'll itself um, start predicting the sequence. I think the OS is smart enough to do that.
Okay, and also the same issue of like before it is flushed to the disk, if the machine goes down, that is uh, that
Yes.
data is lost. That same replication thing happens in Kafka also, right?
Yes, that's right. Yeah, that's a good point. So even here we have a danger of, like, if the page cache is not flushed, we might lose some data. So yeah, so to prevent that, we just have to replicate each partition to multiple machines. Yeah. And Kafka does replicate each partition to multiple machines.
So in an interview, the interviewer is expecting us to go into the level where we tell why is Kafka fast and draw out this page cache mechanism, right? That is
Yes.
what
Yeah.
is
Well,
what he is expecting, right?
so so again, it depends on the interview, right? This is the implementation of Kafka. This is how Kafka is implemented, right? Um, you could theoretically say that. So really, the interview question is not implement Kafka. It is implement a pub sub
Publish
system.
subset. Okay.
So you could technically avoid the whole page cache thing and say that you will implement your own buffer internally, and that might also be okay to the interviewer, right? Because that's also, it's also efficient in a way. It may not be as efficient as just utilizing the internal page cache, because we're adding a layer, like a management layer on top. But um, so both approaches will work. But of course, the page cache one is the way Kafka is implemented. So it's obviously, if you know it and you explain that, that's much better. Yeah, great questions. Other questions? Has anyone used Kafka before? Maybe this was, you guys, this was helpful. I know that Kafka is used pretty much everywhere nowadays, every company. Any other questions people have? Was this clear to people? Like, do people understand now? You can type yes or no in the chat. If is Kafka like clear to folks on the on the call now, or is this something that's still something that's not understood by some of you? So surprisingly, this is something you won't find online. I don't know why, but it's very hard to find a good explanation of how Kafka works online. Um, Even I, when trying to research for this, wasn't able to find anything, and I'm not sure why. But maybe it's because like the internal detail is, yeah. So you'll find everything up to like a high level of what's a topic and how do you, like, up to this you'll find, maybe you'll find this, but not I couldn't even find this, right? It was mostly like, oh, you write to a different partition, and no details about how what the internals are. Probably because Kafka itself didn't have to implement it. Any general questions people have, like about interviewing or applying? Anyone have any interviews coming up, or want to maybe share their preparation strategy or ask questions about it? Yeah, there's someone commenting, still preparing, will take some time. Yeah, that's the way to do it. Like, um, yeah, it's always good to first prepare, um, and then um, yeah, do it in a, like, yeah, it's okay. Like nowadays, it's pretty normal to take anywhere from 6 months to a year to prepare. Um, and surprisingly, people don't want to admit it. Like people want to say, oh, how, if you ask someone how long they took to prepare, most people will say like, oh, 3 months or something. But if you look at the actual time they spent, right, it was probably at least 6 months. Um, like because a lot of them have interviewed before, so they're not counting that time, right? So like when they prepared for 3 months last time, right? So they ramped up to a certain level, and then this time they could continue from that level. So most people spend 6 to 1 year, 6 months to a year preparing. There's a question here: what if recruiters contact you for senior roles with 5+ years experience, but I don't have that? So recruiters are sort of just sending mass emails, right? They're not paying attention to your profile if they're asking you for 5 years of experience. So, just get back to them and see if they're still open to giving you that senior level. Um, yeah, it's probably up to the recruiter. Yeah, any other questions people have? Um, if there's no further questions, we could always wrap up for today. So yeah, last call. Any other questions? Okay, if there's no other questions, then yeah, we'll see you guys next week. Thanks for attending.
Thank you.
Thank you, Harsh.
Yeah, thanks.